first of all, when I first read the question, just before I started recording, it was a bit confusing because if you look at the example here, so if you read the question, at least this is how I read it. Given the head of a linked list, remove the end node from the end. So of a linked list, you stop there, right? So you remove the end node from the end of the list and return its head. Now, if you remove the end node from the end of the list, technically, it's a bit confusing. This is confusing to a lot of people, and I just had to do a quick search because, yeah, basically it's clearer. It's clearer if you would have said remove the end node starting from the end of the list and return its head again. So when you see the end node from the end of the list, so when you say remove something from the end, it just be like go to the end and remove something from there. Right? But when you see the end nodes, it's starting from the end of the list, so you have to start from the end of the list. Which, if you look at it, when you look at this very first example, at least how I looked at it for the first time, it did not make sense. Then when you put the starting from the end of the list, it makes like, okay, you start from the end, then you go back, and then you get the end node, then this makes sense, and it's equals to 2, this is 1 and 2. Then if it's from this other end, 1 and 2, so it doesn't make sense. But starting from the end, then it makes sense, and so does this, and so does this. I just wanted to clarify that because, yeah, that tripped me off. These questions are tricky, and they are not always the best when it comes to be very clear. Okay, so we have to solve this. I'm going to see if I can solve it directly on this LeetCode editor, because I think I've been realizing that we're using a lot. When I code on IntelliJ, auto code generator is on, and then it just it does the entire thing, which is not exactly good because it ruins the experience. So I'm going to try to see, and luckily they have defined the list node here. So I know that from the list node, I know that no matter what I do, all I know is the head. So all I know is this node. I don't know the other nodes. And in order for me to get to any of this node, I have to manually go to all the nodes. There are two. The first approach will be to sort, to reverse this list, right? To reverse the entire list. Then, then traverse the reverse list and get the node. Then that will require two ifs, two loops, right? The first loop to reverse the list, then the other loop to traverse the list. And I think that will, if you have a long list, that takes a lot of time. The second approach, which I don't even know if I'll be able to do it. I don't know if it's possible, but it will be to traverse the list at the same time, try to pick out the end node. I don't know, can we do that? Okay, I'm going to think a bit, right? So if I have to traverse this list, right? So now let's look at the constraints, because n is always going to be less than size. So does n tell, say they say 2 on the n? Well, it does not necessarily mean that there are 2 bits. Okay, it doesn't go. But is there any information we can get that can tell us to do some kind of a mathematics here, so that we can just traverse until we get to this node, and then we remove it and then link it? Is there any information? Because from here we have like n2. If we traverse, no, it doesn't, because it doesn't tell you the size of the list. also there's one other problem. So if you have to, because the first solution, remember, we have to reverse this list and then traverse it to pick this number out, then reverse it again just to return it like this. It's a little bit cumbersome, right? So what I'm thinking of is a method that allows us to just traverse it once and somehow find this node and know that it's at the end position that we desire from this other end. Right? It's at the end position from that end. I know that this has .next, and we can check if .next has a .next. If it has a next, so we have the head has a next, and we can also check. So from a single node, I can check this head. I can check its next, and I can also check the next if the next has a next. In other words, I can go like head. I can do something like head. Let me just do the comments. I can do head next. Next. Let's see. Technically, we can just continue to do .next, of course. How do I do this? So, traverse the entire string. I want to reverse. But this it's not a double linked list, it's just a single linked list. So the double linked list will have the previous. Yeah, this is a bit. I don't want to go through the other. I know that that's the longer method. Yeah, because the method I'm talking about is reverse the list. Right, when you reverse the list, you traverse and you move node at n position starting from 1, and then you reverse back to get original list without. So yeah, to reverse back to the original list and then return, which is it's too much. Let me see. I know that we can, when we traverse this list 1, so we have n2. If we knew this n, what is, if we knew the size of okay. Yeah, so we have not done anything for 11 minutes. 1, 2, 3, 4, 5. Let me see. Are we giving any information? So we can. Yeah, I know that we can traverse the list. this code just traverse the linked list. It allows us to go through all the linked list. It's probably a double wide or something like that. I don't know, I'm feeling like this is the number. Since we don't know the size, and in order to get the size, we need to traverse the entire loop, the entire list. I feel like there's a mathematical equation that there's some kind of a math that we can do here. Maybe let me see. When we go 1, 2, 3, 4, like a double wire. Like depending on this number. Let me see. If we say in size, I want to see if I can get this. If we can do something with the size. Yeah, size. So just put size. Size of array equal to 0, and then we can do size. Yeah, so we get the size there. And now we have we can do int stop equal to, because I'm thinking since we have the size, I'll have the n. So if the size say 1, 2, 3, 4, 5, and n is like 2, our stop will be 5 minus 2, which will be 1, 2, 3. So we want to stop here. But 1, 2, want to remove the next from here, right? So our stop will be well, you can stop here and then you remove this, but I want to stop here, remove this, take the next of this and assign it here instead. You get it? So we'll stop here. So that's the idea. So stop will be size minus m. which will be like 1, 2, 3, 4, 5 minus 2, which is 3. So we stop at the third node. Right? And then we also do a second while node. So it's basically the same code, this code. But now the beautiful thing here I think we'll do is I'm even forgetting to leave comments. Anyway, we'll come back and do these things. Let me see. So let me leave comments here. Stop node where you remove the next node. So from where? So from this node we're moving the next node. And linking the remaining nodes to the stop node. So we'll link the remaining node to the stop nodes, as you can see here. So we found the stop node, and then you go like that. So and then what we'll do is we'll traverse, we'll loop through, so traverse the array again. I saw it twice, right? And we'll stop at this node. So we want to stop at stop node. So when we stop at this node, what we want to do, so traverse the array, and remember stop is a number larger than 0, right? But if we have 1 here and have 1 here, and it's 0, it's greater than or equal to 0. Yeah, so and stop it's greater than or equal to 0. One thing we want to do is we want to decrement stop as we, because you see when we have stop here, stop is say 3, right? When we go, we want to decrement until we get to the 0. Let's see. So actually, you want to decrement because we get to 0, and then I think this is if stop is equal to 0, because that's when we want to. Because when we decrement here, say stop is 3, and it will start here. So we go the first time and we decrement stop. Right, so I stop minus minus. So go the first time and we decrement stop. Go the second time decrement stop becomes 1. Or the third time decrement stop, it becomes 3. Right. What do we do? Where do we define stop? It becomes 3. So do we decrement stop above or below? Below the if stop. The first time stop is 3. Check if stop is second time is 2, third time is 1. Okay, so this goes up, this goes before, right? Remember, we want to make sure that we are on the node itself, right? Because if you go below, then this becomes true when we are here, right? I hope that makes sense. And you see that, because again, so stop is say 3, so 5 minus 2, stop is 3. So when it goes the first time, so it asks stop minus minus, so stop is 2, is stop equals to 0? No, You go the second time, stop minus minus, then stop becomes 1, stop equals to 0. Go the third time, stop minus minus, now 0, stop is equal to 0. Remember, now we are on this particular node. So when stop is equals to 0, what do we want to do? Remember, we want to cut out the next node, not this node. Like the idea is cutting out the next node. That's the idea of determining stop. So we cut out the next node. So we want to do stop. And basically it's not kind of difficult. You just have to do current dot next is equal to current dot next dot next. I think that's it. And yeah. So this current dot next basically is going to point. So you're saying that the current, which is this way you are, the next value should be equals to these values next. So it is the next of this value. In essence, it does this at least. So yeah, I think that's correct. And we also want to end. We don't want to traverse the entire string. We just cut it and end there. So we want to do where and stop is not equals to 0. And stop is greater than 0. So this will run as long as stop is greater than 0. But the moment stop becomes 0, this runs and it comes and check. It breaks this code, and so we just want to return head. Yeah, it's still the same thing, and then we return head. In Java, these are passed as references, so I think if you return head, it does not change. Yeah, it doesn't change anything. Let's see. Oh, okay. That's weird. Let's go into the next slide. Next. So point dot next will be equals to current dot next dot next. Yeah, kind of. Oh, okay, yeah. Let me see. I think there's something supposed to be here. Do that again. Okay, yeah. Okay, so this is good. This is good. Yeah, it feels, I know, but this is good because we are initializing correctly. You see the output, one value is missing, right? So one value is missing here, which means we're moving forward. So technically, I think we're incrementing wrong. size minus n. Size equals to 0. Size minus. Let's see. System print. System dot out. Print. I just want to see some debugging stuff. What's the size? 4. That's interesting. That is interesting. 1, 2, 3, 4, 5. Okay. That is why. We're not counting the first current, so that's a problem. So we are not counting the first current. So we should just start at 1. Assuming that we are not having an empty set. Yeah, the size is always going to be 1, so we will start at 1 then. And I think that should do the trick. Yeah. Cannot do it fire next because no. What do you mean? What I'm talking about here. Let's just comment this out. Yeah, it's 5. Right? Makes sense now. Let's take the ST out of this one. It's 1. Yeah, it makes sense. And then we have this. Current is equal to head. Why current.next is not equal to null. But that's a check. Current.next is not equal to null. It says null pointer cannot read file. No, I don't get it. Basically, it's the same check here. I'm not sure why I'm getting an error. It's 5 minus 2. It's 1 minus 1. Ooh. It does not have a next for. Yeah, this one will not have. But yeah, it doesn't have a next. So why it doesn't have a next? It's not going to. Okay. Okay, I see. I think one of the test cases will pass, but I'm guessing that this is what's causing the issue. A test like this. So a situation like this is going to cause the issue because I'm checking while. But again, it's not supposed to cause an issue. At least it's supposed to just give me a head of one and return it. So I'm not sure why I'm having the problem here. Cannot read file view next because it's null. Look at the it's null. 29. So if it's an empty set, but the constraint says it's not supposed to be an empty set, so I don't get it. Let me see. Yeah, it's not. Am I missing something here? Or it is equals to head. There's something I don't know. I don't know what. I actually don't know what I'm missing here. It's same check, right? I'm simply just reassigning the head back to the initial head here. Remember, I'm not manipulating a string or doing anything in a string. So if I do the reassignment, it should start back at the head, and this check should still be valid at even within an empty set. So if I have an empty set, so it does not have a next. It cannot read field next because local takes none. I don't get it. It's weird because if you put 0 here, you put 0 there, it works, right? You don't have the error. Yeah, but when you do the 1 there, actually computing the size of it, you have the error, which does not make sense. It doesn't make sense. Let me see. List node current 2. I don't know if it's that I'm using the same variables. Look, at this point, I'm just trying out stuff. I know it's a terrible naming convention, but I don't know what to do. I'm not sure why it is. It's still the same problem. I don't know if it's to 0. I don't know. Yeah. Yeah, because it doesn't have to do that. I don't know what's happening. Seriously. I don't know what's happening here. Okay, so I have a stop. Okay, I have a stop. And then I just want to comment this out first and see if something changes here. Yeah, it does. Nothing happened. Right? So I'm traversing the string fine. Right? So this has next. And I guess this is where the error comes from. Okay. I think we are having a problem here. We're having a problem here. So we'll basically just do is not equal to null. Then the ternary operator, we're going to copy this. Else we just put null. That should solve the problem. Are you kidding me? So I'm saying coin.next is this .next. Why? Because okay. Yeah, I know that that's the problem. I know that that's the problem. Because I'm stating, you know what, I want to do a couple of system.out here. System.out. Yeah. Should be equal to, oh, sorry. I want to do coin.next. Yeah. I also want to do this. Next. No. 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 This one should fail. Okay, let's revise this logic a bit. So first of all, I think that, well, you know what? Let's check something first. This should fail. I have to have that. Yeah, I get it. Yeah, so that's 4, right? And I am assigning current.next. So I think the problem comes somewhere here. This next one. This is my problem. I'm trying to do next, right? With value. I think that's where the problem comes in. Yeah. So maybe because there is this here, right? There's this. And you just assign current.next, yeah, that makes sense. And then you assign current.next. Yeah, this makes sense because number 2 will not have that. This one will have it, but the other question, these other ones will not have it. And the check here just basically okay. So this check here is good. But what I'm thinking that we're having, at least for the first issue, is that again we're coming and we're doing current.next after we've assigned, say, null. And we have current.next, which is null. Okay. So the idea is, okay, what I'm trying to do here, that the first thing is that I want to assign this to the current.next. So current.next is equals to this. And basically I will just also I will see. Just maintain the null. Still having the same problem. Okay. Alright, so good thing. Okay, let's rewind this. It's taking longer than I expected it to, and it's just this logic here which is annoying. There's also something I'm missing here, but we'll get to it. We'll fix this. So this makes sense up to this point, but I think the problem comes in assigning this value to n, right? So we are trying to say the current, which is 3, because we print coin dot value, then we should have 3 there, right? Because the last time we did coin dot next dot value, which was this, they had 4. If you just rewind the video, you see that. But we print coin dot value, we have 3, right? So we want to say coin dot next is equal to we want to do list node next. Okay, so we coin dot next, right? And then I don't know if this will work. So basically, we're saying that the list node, this next will be this one, right? And so we want to go, so coin dot next, which basically is the current one. But we're trying to assign the next value will be the next. So we want to say if next dot next is not equal to null, then we want to go next dot next. It's the same thing that we did. Oh no, it's the same thing that we did for the other one. But when we have 1 year, right? When we have 1 year, this list node does not have null. So next is equal to null, then current dot next. So basically, I think this case is a problem. I think there's a case which is a problem. Let's try to see which. So size is equals to 1. Then size is equal to 1. Just return. Yeah, that's not helping either. I am not sure what's happening here. I'm missing something. I don't know what I'm missing. I really don't know. Why current.next is not equal to null? That makes sense, right? That's I'm saying that go through the string while the current next is not equal to null. You continue going through the string, which means I don't know. I don't know why. Why am I having an overflow? I don't know. But it's something concerning this logic here. Yeah, I know all of them are going to be false. But here is what I am. So this case works. Else. Maybe. Maybe. Yep, that's the problem. So I was doing the coin.next twice either way, so I don't need to put this one within. And okay, yeah, this is the problem I talked about the other time, which is the, so you see we're outputting 0 instead of 1, so basically say new this node, this node, public this node. Just return now. Yep, so that took quite long, too long. Doesn't make sense. That does not make sense. Okay, let's correct some of the logic. So our logic is going to find the total array, which is 2, the size, which is 2, n is 2, 2 minus 2 is to 0. Oh yeah, so basically there's this, right? Yeah, this is what I never wanted to happen. We put equal to there, right? Then this becomes 0. So we have 2 equals to 2 equals to 1, and so we're using this one here, which is, it's not the best idea. And I solved that one the other time by doing this. Where is it? Where is it? Yeah, doing this, which is not also, it was just to pass this test case. But the real problem is here. while current.next is not equals to null and stop is greater than equal to 0, is greater than 0. If I put greater than equal to 0, then I think this stop should go under. But then we're going to have an issue because we're going to be on this. Okay. Okay, so if we put equal to here, I think it will solve this test case if we put the stop beneath. But then the other test cases fail because we're going to have 3, which is going to go the first time, and it's going to check which is there's going to come here, which is not what we want. But we also want to check because we want to stop exactly here, right? Equals to 0, greater than equal to 0. I want to stop when stop is equal to 0. That's when we want to go, but at the same time we want it to be here, current. Okay. That'll be the first time. Okay. There we do stop -1. The second time, stop -2. The third time, stop. Okay, I see a problem. It's just okay, the first approach we're taking is that we want to stop here, right? So we find the size, and then we use the top size. Yeah. This is 0. This is 0. this is 0, and then current equals to head. This becomes, so it goes the first one, but it doesn't run here. So I know that is going to be greater than or equals to 0 here. But like I said, yeah. Yeah, so this, 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 less than or equal to 0 go, but I think it's a wrong algorithm. It's just wrong. Let's feel somewhere else. Yeah, I knew that would work. I think it's, I'm missing something. It's not supposed to be this one. I'm missing something. I'm missing something here. Because okay, so that'll be the first one. When it goes in, then it's the first one, right? What I want to do is decrement stop. Okay, I want to decrement stop later. Right? And if we do that, then it comes, we are working with this. This is a node. Then we are forced to have another something like a previous. Right. Previous is also equal to head. That's a current. Current here. At this point. Then what we want to do is take previous and assign it to next. So our current previous.next. So previous will be equal to current. I just leave it there. Previous will be equal to current, and current equals to current.next. And so we can take basically previous.next. Previous.next equals to current.next. For this one, you go 2 minus 1, that's 1. Which is going to be the first one, is stop equals to 0, no. Previous equals to current, and current equals to current.next is 2. Nah, that's still wrong. That's wrong. What am I missing? Previous equals to current, current equals to current.next. It's supposed to be easy. I'm taking too long. Stop equals to 1, right? So 0. So you move to the next, which is 2. It merged to 2. We're dealing with stop, which we're moving the stop. We were checking if stop what? We do int count equals to 1. Alright, and then right here we do check, rather than check if stop equals to stop, we do count equals to stop. just increment count instead. Plus plus. Does that work? Okay. All right. So the first thing we do, we find stop, right? And in this case, we want the stop to be on it, right? So which will be n minus 2, will be n plus 1 minus 2. So, sorry, size plus 1 minus n, right? So basically I'm updating, I'll explain later. So you have to be this, size plus 1 minus n, it comes here, and then we have current equals to head, previous, we have the previous, and then we have the int count 1. So we have y current is the next, y it has next, the this, okay, we'll put that up there, and count is less than stop, right? Because should be less than or equal to, because if count gets greater than, then it's not. Less than or equal to stop. They will check if count is equal to stop, which means that when we are here, we want to do that. Else, we do that, we increment count. So let's run this manually. It's going to get, that is 1, 2, 3, 4, 5, 6 minus 2, which is 4, 1, 2, 3, 4. And since count starts from 1, it's going to do count equals to stop, which is 1, no. Count equals to stop, which is 2, no. Count equals to stop, which is 3, no. Count equals to stop, which is 4. Yeah. So 1, no. 2, no. 3, no. 4, yes. And then it's going to take the previous, which is this, and concatenate it and merge it with this other one while moving this one, which is true. And then the count plus plus, which then count exceeds stop. Now, for case 2, is going to have, which is n minus 1, which is 1, 1. Right? So stop is going to be 1 here. So size plus 1 minus n, which is going to be 1 for this case, which is 1 plus 1, 2 minus 1, which is n is 1. It's going to be 1. Then we're going to have, yeah, current equals to head, which is 1 there. And we're going to have count. And then we're going to have dot current dot next. Does it have next? No. So it's going to skip this. But we tackle this up here, where size equals to 1, because n should also not be greater than size, as you can see. Yeah. So this tackles this case. And then this case where we have 1, 2, and we have 1, n equals to 1, is going to go 3 minus 1. So because the size is 2, so it will be 2 plus 1, which is 3, then minus n, which is 1, is going to be 2, right? So 0 starting from the end, we want to move 2, so at 1, 2. And so we'll do, does it have next? Yes. Is count less than or equal to? Yeah. So y count has next, and count is less than or equal to, count is stop. So count is 1 there. So we're going to check is count 1. Yeah. So this is 2 here. Stop is 2. Which doesn't make sense. We're going to go count is 1, and this has next. But these don't, the second time it will not have next, which is not cool. It's not cool. Yeah. Technically, we don't even have to. Do we? No, we don't. We can just move this argument here and then run it. Yep, that argument runs. So it passes all the test cases for these two. But does it pass this test case? Let's run this manually before we can run it. Head 1, 2, so the end is 2, so it will be 3 minus 2, which is 1. So we need to move it at 1. Count is 1. So you run this, count equals to that. So what's the previous? Here is current. Current is, so previous supposed to be null. Previous next. That's a problem too. Yeah, okay, that still passes. So previous or next. So what's previous here? Previous is null. So previous dot next is equal to. So we do want to make sure that if previous because null does not have next, so it's going to throw an error here. That's the problem. It's going to throw an error. So the null does not have next. Okay. We have to tackle the case where we're moving the first element, which is a problem. Then head. So if count, let's do a little bit of else if here. We do if. So if stop is equal to 1, not here. Simply do, so we'll calculate stop here. So if stop, so what to do is stop, if stop is equal to 1, right? We simply just want to remove the head. We want to remove So if stop equals to 1, which means we're removing this one, we simply want to do return head next. Yeah. And then this stays the same. Okay. Yep, there we go. Okay, so this is good. This is really good. And also, our solution is very optimized, very, very optimized. So that's great. That's super great. Anyway, so we spent a total of 1 hour 25 minutes. Which is a good time. Yeah. So that's why a lot of memory was used. So yeah, but this was really good. The uptime efficiency is really good. So that's our solution. I hope this makes sense. Again, a recap for what we did. So basically, there were two approaches. We could reverse the list to start from here, which means that we have to traverse it first while reversing it, and then take the index and traverse the list to move this one, then rearrange the list or invert the list back to its original size, then return the head. However, that's very inefficient. The way I thought of doing it is, first of all, get the size, right? As you can rewind the video and see, when we have the size, we can do a little bit of math, because basically we have to remove an nth value, and when we get the size, we get the total number of nodes within the list, and so we can simply just make a subtraction. And normally with a list, because we're starting at 0, at 1, with the list, when you get the size of a list, like an array, you always have the index at 0, but here the index starts at 1. So we need to add 1 in order for us to do this. I don't know how to explain that really properly, but in other words, we do a subtraction in such a way that it allows us to focus just on this one, right? It allows us to be on this position, the node which we're supposed to remove, right? So in essence, we're saying that our stop point when traversing the list is this node. And in order to do that, we do size plus 1 minus n, right? So basically the size plus 1, and then we'll move n from it. Stop node 2, remove, not to be removed. So let's update the next node. So find the stop node to be removed. And then we start from the top. So we find the stop node to be removed, and then we handle removing the head node. In cases where we have to remove the head node, we simply just remove the head node. We don't need to traverse the string. And then traverse the array, right? We have the current, we have the previous, we have the count. Now the count is to count the number of nodes, the number of time we have traversed this list. And so when we count that, each time we count and it's not equal to the stop node where we are supposed to stop. So each time we are at a node which is not the stop node, we want to set the previous node to the current node, and then we set now the next node basically. That way in the next loop, which is basically current equals to current next, which gives us our current node when we are in the current loop. It's a bit for those of you who don't know looping, it's a bit tricky, but I hope this makes sense. So when we do that, we check if we are at the stop node, and when we are at the stop node, we want to take the previous node, right? So basically when we are at the stop node, for in this case, when we are at this node, what we want to do is remove this node, and in order to remove this node, we need to connect this node to this node and remove this one, right? And so this is what we did here. We take the previous node, so we set the previous dot next, this pointer that points to this node, we take it and set it to this node. By doing that, the current dot next, which I was talking about the current and how confusing it is. Yeah, linked list is a bit confusing, especially in explanation where you use current, next, blah blah blah. So yeah, so that's our solution, and this is really good. This has been really interesting, and I hope that you enjoy the series. You enjoy the series thus far, and you enjoy this video. Please like, comment, and subscribe. Quick below, if you have alternative solutions to this, your different approach to this, you can leave the solution below or just talk about it, and it will be nice for me to understand your approaches and see what you're thinking. You give me another point of view. However, today we had a really good day. We beat 100% in the time, so we are on the first, right? So, and then the rest are stuff, which is good. Again, in our solutions, we always test I also show, so I'm not going to take long, sorry, I also show a solution from LeetCode, which is the provided solution editorial. Okay, so anyway, we can just click on an alternative solution. Yeah, most of the time, most of these people just copy from ChatGPT or something and put it inside there. So I think if you ask GPT, it will give you exactly the same thing, but again, everybody has their own stuff. So this is it. Say list dummy equals new list node dummy dot next head. Fast, slow. I don't know what's the second. Okay, this is just for the one time. I wanted to check the space complexity there. So just go through this and basically learn what you can. I'm not going to explain this. It's already too much time. So like, comment, and subscribe. Thank you very much. See you next time.